and agroforestry. Then we'll go into my research questions, methodology, and then there's kind of two stages of this research project, which is a pilot study from 2019 through 2020, where we tested some of our research tools. And then I hope to have time to go into my current research activities, which will be starting here on Sunday. We're going to be heading up north to start data collection. And then we'll be talking about our expected outcomes. So first, food security in Zambia. Agriculture supports about 70% of the total population of 17 million, but it only accounts for about 7% of the gross domestic product. There's high poverty in rural areas, about 77%, and people experience chronic household food insecurity and malnutrition. That food insecurity is linked to low agricultural productivity. Problems associated with productivity include poor soil fertility and management, low diet diversity, diminishing access to land, limited access to inputs, infrastructure, and markets, and then limited government support through extension. So to address some of these food insecurity problems, Zambia began promoting aquaculture in the 1980s to address those problems that I mentioned. Development first prioritized rural areas to support livelihood diversification and income generation. Fish are a culturally preferred food in Zambia, and fish are rich in protein and micronutrients, and increased access to fish has been linked to improved nutritional security for early stage child development and resource poor communities. But also it was promoted as a way to optimize resource use, such as this farmer that you see in this picture here, who's using the fish pond to intensify vegetable production and fruit production on the dikes of their fish pond. So this practice that was commonly promoted is called integrated agriculture, aquaculture. It's kind of a way to introduce aquaculture into the farming system and manage it with low inputs using village appropriate methods. In IAA, earth and ponds are integrated into the existing farm system, and wastes and byproducts from other farm enterprises are added to the pond to supply the necessary nutrients for fish production. And then in turn, aquaculture intensifies the productivity of associated enterprises, like providing irrigation opportunities for crops, and then also the addition of nutrient-rich silts that can be harvested from the pond bottoms and used to fertilize crops. The primary fish species cultivated in Zambia are native tilapias, such as Orichromys macrochier, andersoni, and the red-breast tilapia, Coptodon ridali. However, since aquaculture systems are typically open to the natural water bodies, farmers typically manage polyculture or mixed species systems that can include catfish, mouth brooders, and barbs and minnows. So since the 1980s, there's been a wide-scale adoption of aquaculture in Zambia. And in particular, commercial aquaculture in peri-urban areas of southern Zambia have grown substantially in the last decade. So Zambia is now currently the largest producer of farm fish in the Southern Africa Development Community. And they're the 6th largest producer in Africa, generating about 36,000 tons in 2018. So presently, aquaculture in Zambia ranges in its management intensity from commercial to small scale. Commercial operations such as this cage culture operation in Lake Kariba, they strictly use intensive inputs like commercial feeds and fertilizers. And they sell primarily to urban and regional markets in southern provinces. However, small scale and semi-commercial and subsistence farmers here on this end of the spectrum, they manage for both home consumption and direct sales to their neighbors or local markets. And just to give you an idea of kind of proportions of fish farmers, ones doing more intensive culture are only about a few hundred farmers in the southern province, whereas over 7,000 farmers are participating in small-scale, semi-commercial and subsistence farming in northern provinces. So that's the majority are in the north. So these are two figures from a countrywide livelihoods assessment of small-scale farmers conducted by Kaminsky et al. And they show the differences in asset endowments and the types of feeds and fertilizers that are used by small-scale farmers in northern and southern provinces. So here, northern provinces are colored in red, and farmers in the south are colored in yellow. So figure A shows that both northern and southern farmers have comparable access to assets like human capital and social capital and natural capitals, but the major difference in their access to resources comes in like physical infrastructure, such as roads and markets and housing infrastructure, and financial capital like the access to markets, the access to credit, and the household purchasing power. And so these lack of markets and infrastructure leads to a major divide in the management of these small-scale farms, where the South mainly utilizes more commercial inputs, as you can see in this graph B, whereas the North, they use lower quality vegetative inputs like plant residues, which leads me to the most important topic we're talking about today, which is fish feeding in integrated agriculture, aquaculture systems. So I'm going to be discussing this in detail throughout the presentation, but fish feeding in these systems can be grouped in two distinct strategies. One is natural feeds and supplementary feeds. So natural feeds are supplied through the fertilization of pond waters, either through the addition of livestock manure or crop residues that are composted in the pond. So as the additions of organic matter decompose, they release nitrogen and phosphorus, which stimulate the growth of algae. And algae are the foundation of benthic and planktonic food webs that feed fish naturally. So in addition, some fish species such as Orichromis macrochier, they possess a specialized toothed pharyngeal bone, like in their gill slits, and that facilitates direct feeding on vegetation, but that's only certain species that are cultivated in Zambia. So recommended rates of fertilization are 3 to 4 kilograms of nitrogen per hectare, a figure that we'll be discussing later on in this presentation. The second way that are fed are through supplemental feeds. And this is because an ecological threshold exists for natural feeds due to water quality issues caused by nutrient loading and oxygen depletion when you put manures and other fertilizers into the water. So fish yields can be further increased past this ecological threshold through direct feeding with homemade crumbles that supply additional energy through carbohydrates, usually through staple crops that the households use, but also protein and fats like oil seeds, fish meal, and and the leaves from plants that are soft and nitrogen rich and low in fiber. So this is just to give you an idea how homemade feed crumbles are made. The ingredients are mixed dry, and then water slowly added to create a paste, and then the crumbles are laid out in the sun to dry and then fed directly to fish on a daily basis. So 84% of farmers in northern province, they still rely on integrated farm systems to support feeding regimes, whether or not they have access to commercial feeds. Recent aquaculture studies have used participatory approaches to identify the most common challenges that farmers face when managing these integrated systems. And farmers consistently report a low availability of resources on the farm that support these fish feeding regimes. So there's been a few studies, and development researchers have recommended a mix of intensive and context specific extensive strategies for feed and nutrient management. However, there's a recognition that, so like if we're talking about intensive management, there's a recognition that even if markets were expanded into rural areas and farmers had access to more intensive inputs, that many households don't have enough purchasing power to even afford commercial inputs should they be made available. So that means a lot of concentration is being put on these context-specific extensive strategies or enterprise diversification to optimize the resource flows at a farm system level. So that brings me to agroforestry. Agroforestry is an integrative practice that may provide some of these context-specific opportunities for fish farming households. Just to provide a definition, agroforestry is the intentional integration and management of trees in agriculture systems, either simultaneously through integrative spatial arrangements or sequentially through time. So in addition to products like fuel wood, livestock fodder, and timber, agroforestry is known to provide a range of regulatory and supporting services in agricultural systems. So these services include the conservation of soil and water resources, carbon sequestration, as well as the improved cycling of soil nutrients through the addition of organic matter. So just to mention a few recommended agroforestry practices specific to Zambia, extension concentrates on indigenous fruit tree cultivation, the harvesting of non-timber forest products, the management of intensive woodlots, as well as the intensive management of leguminous trees. The leguminous trees can be managed in open canopies, like you see this Fadeherbia intercrop here, that provides a biomass transfer and nutrient transfer to the crops below, or a coppicing regime, like you see this Gliricidia intercrop, where trees are cut back and the biomass is transferred beneath crops as a mulch to fertilize crops. And they can also be used as an improved feed for livestock. So many tree species and tree products have been studied throughout the years for use in specifically aquaculture, but this research is limited. So tree products can contribute to aquaculture in a few ways: through natural feeds, like we talked about, through rotten fruits and leaf residues, through supplemental feeds. There's been a few species of trees that have been researched as a protein replacement for fish feeds. So soft, nitrogen-rich leaves from moringa, papaya, mulberry, and lucina have been studied, and the results from these studies suggest that these leaves can replace up to 25% of the protein requirements for fish without adverse effects on fish growth. But there's a limit. So unfortunately, the use of these leaves is limited by palatability and digestibility and the presence of anti-nutrients. So anti-nutrients are compounds, like amino acid compounds like tannins, if you've ever heard of those. And they tend to bind to proteins within the fish's digestive tract and limit the digestibility of proteins. And so that's why they're called anti-nutrients, because they lock up nutrients within the fish's gut. If we consider other uses that tree products have, we can consider fuel wood for fish drying and smoking, which is a big deal in Zambia. There's a lot of deforestation that happens as a result of the fisheries industry, and the preservation and the processing of fish products through fish smoking. And finally, as previously mentioned, agroforestry can intensify the production of livestock and cropping systems that are integrated with aquaculture and supply the inputs to aquaculture. Here's the problem statement. Research regarding both agroforestry and integrated agriculture, aquaculture, is extremely limited, especially in the Southern Africa region. So it's a little complex. Optimizing IAA requires context-specific knowledge of household livelihoods, farm management, and seasonal availability of bioresources. So it's hard to get this data. And appropriate practices that we could recommend would depend on the knowledge, perceived benefits, and limitations among smallholder farmers. So our overarching research question is this: does agroforestry improve the bioresource use and fish feeding regimes within integrated agriculture, aquaculture systems? And because this primary research question encompasses the entire farm system, we have multiple sub-questions to address, and the essential ones are: how much does aquaculture contribute to household livelihoods? What specific bioresources and management regimes are preferred by households, particularly in conditions of seasonal feed shortages? What socioeconomic and agroecological context do farmers exploit tree products within these integrated systems? And do integrated systems having greater levels of integration between aquaculture and agroforestry have greater productivity or fish yields? And finally, does agroforestry address any of the local specific challenges that households face when managing these integrated agriculture-aquaculture systems? So we'll be conducting this research in Luwingu District, Northern Province. Luwingu District is mostly rural with low population densities. The landscape is a patchwork of the Miombo woodland, wetlands, rivers, villages, and croplands. The district is situated in the northern regions of Lake Bangweulu and has a dense network of meandering streams and natural springs, and that makes it a perfect region for the expansion of aquaculture. In the region, agriculture and fisheries are the main economic activities, and the market infrastructures are concentrated around Luwingu town, which is connected to larger regional markets in Kasama and Mansa and the Copperbelt to the west. Just to give you a brief overview of farm systems, the climate in Luwingu is subtropical and monsoonal. The rainy season lasts from late October to early May, and rains approach 1,400 millimeters per year, with an average yearly, 1,400 millimeters per year. And like for Americans in the audience, that's over 55 inches of rain per year, which is a lot of rain. Soils are highly weathered, they're sandy, they're acidic, and there's low nutrient and organic matter retention. Further, agricultural lands are managed by a process known in Bemba as ichitamane. It's a local form of slash and burn where trees are piled up in the fields, and they're burned to release the nutrients for crop production. Nutrient availability is highest in the first year, but then it steadily declines over the next 2 or 3 years. And once soils and nutrients are depleted, the field is fallowed, and the farmer moves on to begin the cycle again. So for our study, we're using a case study design using both qualitative and quantitative approaches, and we're using sustainable livelihoods, agroecology, and food sovereignty theoretical frameworks. So the sustainable livelihoods focuses on environment specific conditions, and it uses responsive and participatory approaches to enable communities to address their own needs. Agroecology is the application of ecological principles to understand food and farming systems, and both agroecology and food sovereignty recognize agriculture as a social and political process, and they center around the knowledge and agency of indigenous peoples to determine their own food system policy and practice. Can you hear me?
Yep, keep going.
Oh, okay, great. So our timeline of activities is stage 1, which is already complete. We did a pilot study from September 2019 to March 2020, which Malaya here kind of headed. And here I was testing data collection tools, and later on I did an analysis of secondary data that was generated by Malaya, and it was provided by World Fish. And then hopefully I have time to talk about our second stage, which will be starting in November and December of 2021, which is a farm system analysis of these integrated systems. So data collection for the pilot study took place within an extension and training program that was hosted by World Fish and the Ministry of Fisheries and Livestock. And it targeted women who were recent adopters of aquaculture and trained them in fish stocking and feed formulation and human nutrition. So 19 farmers from the training sessions were recruited to maintain daily feed journals that document the inputs that they put into their ponds over 160 days from September to February in 2020. The farmers itemized bulk inputs in 10, 20, and 50 kg meal sacks, and then they itemized smaller inputs using locally sourced containers like cups and buckets, things they could find around the farm. So technicians, mainly Mulea here and his colleague Lulu Middleton, they visited farmers in person on a monthly basis to check in, collect the journals, and verify the entries. So this is an example of some of the journals that we collected, and it just lists a date, the ingredients that they used, and the quantity that they used. So I came in and I entered the scene at Project Inline in February 2020, and we administered a short pilot questionnaire that inventoried forest resources on the farm and qualified tree product management and ranked the tree products according to farmer preferences. So once I got all the journals, I compiled a complete list of all the feed types and yields. And it ended up being over 3,000 individual journal entries. And I summarized those yields into 10-day increments to create 16 10-day periods. I used a principal component analysis to reduce the dimensionality of that complex data and to identify a variation of feed types used throughout the study. I used a variance-covariance matrix, and the PCA results were used to group feed types and plot the yields through time to understand the seasonality of the different feed type uses. So briefly, I'll go over the participant descriptive statistics. They were all women, aged 40 to 50 years, with a household size between 7 to 10 people. Households generated low yearly disposable income, and most of them experienced relatively high food insecurity and access. They managed about 1,000 meters squared of pond production area, and that was divided between 4 ponds. So this picture is an example of one of the participants, and it gives you an idea of the production area that they're dealing with. The fish, we did a random sampling at the end, and of course polycultures were present, but the outbreak of the coronavirus disrupted a proper assessment of yields and fish composition within the ponds, which is a bummer because we were hoping to get an assessment of productivity, which we were unable to get. This is a table describing household food systems for the 19 participants. It's a busy slide, so I'm going to quickly break this down piece by piece, just to give you an overall idea. Primary staple crops that farmers grew were maize, groundnuts, and cassava on a farm size of about 2 hectares of land. Farmers maintained home gardens that mostly contained leafy greens and sweet potatoes and pumpkins, as well as fruit orchards of about 14 trees that were mostly mango, citrus, and guava. Households owned very few livestock, and so generated very little manures on the farm. Farmers mostly owned poultry, and a few owned 2 or 3 goats. Some owned swine and rabbits, but mostly it was poultry and goats. So to begin with the inputs that farmers used, manures were purchased off farm because, as I said, farmers owned few livestock. The input rates for manures were 1.3 kilograms per meter squared. What does that mean? Basically, it means if you broke that manure input rate down to elemental nitrogen, you would get a mean of 1.2 kilograms of nitrogen per hectare, which fell below the recommended rates for productive aquaculture that we mentioned there in the beginning. So most fish farmers aren't putting in enough manures to provide for productive aquaculture. These are the results of my principal component analysis. I won't go into the intricacies of PCA, but basically this output tells us what fraction of the variance between feeds is captured by each of these principal components. So if you add PC1 and PC2, you get about a 46%, which means 40% 46% of the variation among the feeds that were used among farmers were explained by the groupings in this graph. And if you look closely, you can see that the analysis grouped feeds according to what we talked about in the beginning, which are supplemental feeds like oil seeds, maize, and cassava meal. And then it grouped it according to natural feeds or additions to promote natural feeds like crop residues. These guys here in the middle are a third grouping that represents feeds that were used intermittently and in low quantities. So if I took those groupings and I assigned our yield data, the groupings that were identified to the PCA, and we plot it through time, we get these yield graphs. And it gives us a picture of resource seasonality over the 160-day period. So on the x-axis here, you can see these 16 10-day periods that I use for analysis, and on the y-axis you can see kilograms of dry matter over each studied period. So you can see that the use of supplementary feeds here in this grouping here, labeled in red, were highly seasonal. So farmers use these feed types mostly during the dry season. And although our study didn't do follow-up questions to ask about the seasonality of feeds, this is typically a time preceding the previous year's growing season when the crop harvests are most available. So if we move down to garden and crop residues here, we can see it's also seasonal. And the use of garden and field residues were mostly used at the onset of rain. So farmers were clearing their fields and they had access to large amounts of compost and residues, which they transferred to their fish ponds. But both supplemental feeds and natural feeding resources dropped off by January, and levels of additions were pretty low. So where do tree products fit into all of that? 6 farmers that we interviewed reported using tree products as fish feed. 13 different tree species were used as either natural feeding or supplementary feeding, but they were used in low quantities. So reported proportions that farmers said, 3 farmers used less than half of their inputs as tree products, and another 3 said they used an even smaller amount, about 1 to 10%. So tree products were mostly collected around the homestead and fish pond, excuse me. So the top contenders for fruits, rotten mangoes and wild loquats, or locally they're known as amasuku, were frequently used as pond inputs. These are additional inputs. These are direct observations that pictures I took in March of 2020, right before I was evacuated, of trees that were used as direct inputs in aquaculture. So picture A here shows a farmer who planted an orchard of moringa, and she describes stripping and drying and pounding the leaves to add to her supplementary feed. Picture B here shows a farmer using Gliricidia sepium as a shelter for their livestock and as a feed for their pigs. Picture C shows a boundary planting of Senna spectabilis, which is right here. And the farmer reported harvesting the evergreen leaves because they don't drop their leaves during the dry season, and the farmer depended on this tree when little vegetation is available during the dry season for composting. And finally, which I was most impressed with, is picture D, which is an intentional fodder bank that was planted on the bank of a fish pond. And it's a mixture of Napier grass and pigeon pea. And the farmer reported slashing these materials so that he could dump them directly, she could dump them directly into the fish pond. So that's kind of an efficient management strategy for vegetative composting. So our main takeaways from the pilot study were that few conclusions can be made. I'll go over a few, but keep in mind that all farmers were recent adopters. They had just adopted aquaculture, and they were participating in an intervention study, which kind of like clouds some of the objectivity of what we're doing. The effects of feeding strategy on fish productivity are unknown because we couldn't harvest the ponds. For natural feeding regimes, just as a reminder, manures were mostly purchased off farm. The nitrogen inputs fell below the recommended rates, and composts were mostly cassava leaves, pumpkin leaves, and sweet potato leaves. And those mostly occurred as bulk additions during field preparation in the early rainy season. Supplementary feeds, farmers used mostly maize and cassava meals with additions of purchased soy and vegetable oils, and most supplemental feeds were added during the mid-dry season. So the reasons for seasonality are unknown because we didn't follow up with more qualitative questions about why farmers were doing what they're doing. Tree products were used by relatively few farmers, and when they were used in low quantities. So I'm going to briefly go over what we're going to be doing here in the next few months up in Luwingu. We're leaving on Sunday. So from November to December, we're going to do a farm system and resource mapping and resource flow analysis on these farms. And hopefully we can facilitate comparisons between farmers who are utilizing agroforestry and farmers who don't use agroforestry within these systems. So we're going to be accessing the Ministry of Fisheries and Livestock database, and we're going to do a random sampling of about 60 active fish farmers in Luwingu district having at least 3 years of experience. Excuse me, I said random sampling, I meant purposeful sampling because we want to identify 2 treatment groups for comparison. We're going to talk to like a baseline group of farmers, and as we talk, we're going to identify farmers who are using trees. And when we identify those farmers through the questionnaire, we're going to ask them if they know of anybody else who's using the same management practices. And hopefully by the end of the study, we can get 30 farmers who are using tree products and 30 farmers who don't. Our questionnaire lasts about 2 hours, and it assesses all the farm activities that were done in the last year. It includes discrete and open-ended questions, inventories of farm system resources, and as well as preference ranking of the way farmers use these resources on their farms, how they prefer to use it. We're going to collect socioeconomic measures such as household food insecurity and access. We're going to do an itemization of household assets and the livelihood strategies. So what activities generate the most income within the household? We're going to discuss qualitative issues such as, how satisfied is the farmer in their agriculture activities and their aquaculture activities. We're also going to ask them about the management challenges that they face both in agriculture and in aquaculture. And then conceptually, we're going to break down the farm into individual enterprises for analysis. And those farm enterprises will be aquaculture, of course. And then we'll also analyze primary cropping systems, home gardens, livestock, and agroforestry systems. So this is kind of like a resource flow analysis of how this questionnaire will collect data. We're going to quantify inputs from each enterprise that I just mentioned, and we're going to get a species composition. So this is like an ecological term. It's going to give us the number of species that farmers are managing and the abundance of each of those species within the system. We're going to itemize resource inputs and also the seasonality of those resources, which we saw earlier is a pretty important in terms of input additions. Then we're going to ask more qualitative questions regarding enterprise management. So we're going to focus on best practices that are recommended for each enterprise. We're going to discuss the household labor roles that are assigned to gender and generational groupings within the household. And then, like I said, we're going to discuss the management challenges that farmers face in each enterprise. And then we're going to quantify the outputs from each enterprise. And that includes outputs for household consumption, income generation, as well as the bioresources that are generated for recycling back into the system. So those can be recycled back into the original enterprise or into other enterprises which gives us an indication of the level of integration that occurs in these farms. So we're going to analyze quantitative data using non-parametric statistics for preference ranking, correlation, regression, and ANOVA. And specifically, we're going to explore relationships between the enterprise outputs like income and consumption and the resource recycling with socioeconomic measures. And then for qualitative data, we're going to identify categories and themes through open and focused coding. So our project outcomes, we're hoping to better understand the synergies and the trade-offs that exist in the bioresource base of integrated farm systems. And we want to consider strategies for low-income farmers to adaptively intensify these systems according to their own resources and capabilities. And these results will ultimately directly contribute to the ongoing effort for developing sustainable systems that optimize resource flows for aquaculture in Zambia. So hopefully I'm within time. I think I am. And I'll open it up to questions.
Thank you so much, Jacob.
Sure.
Perhaps you could remove the slides, then we can all more easily see one another.
Sure.
All right. Well, everyone, please feel free if you have a question, either raise your hand or put it in the chat. But maybe while everyone is thinking, firstly, Jacob, let me just say how beautiful your slides are, how gorgeous. Okay. Oh, you clearly put so much time into the pictures, and I just felt like I was there with you in Zambia, and I just really appreciated that. So really nice job.
Yeah. Hey, and I'm open to any questions you have, but just as a reminder, I invited Malaya here because I wanted to give you guys the opportunity to have a specifically Zambian perspective about aquaculture production and kind of the impacts of these systems. So.
Yeah, no, wonderful. I see you guys are a total team, total package. So look, Clement, you have raised your hand. Thank you. So please, over to you.
My hand was up first.
You are.
Okay. Jacob, your partner, thank you very much. That's really wonderful. My question is there a monitoring system in place as to who monitors these aquacultures are monitored for quality, safety in terms of the fish production? Because I have watched some documentaries about this fish farming, and some of them, the feeds that they give the fish, they have chemicals. So I'm just wondering if somebody in Zambia monitors this project. And then who purchases the fish from especially the low-income practitioners? Who purchase the fish from them?
I know the answer to the second one. Maybe I'll pass off the first one to Malaya about quality control.
Under the Ministry of Livestock and Fisheries. But then the monitoring is not done effectively due to low staffing that exists within the ministry. Then I think they also work hand in hand with the Environmental Management Agency, but due to low staff numbers that are there, I would safely say the monitoring is not properly done. So I don't think there are people that do monitor the feed quality, because I think in the last, just in yesterday's interview where I was interviewing one of the farmers, one of them did mention that they fed their fish low quality feed under the Zambia Aquaculture Development Enterprise Project. And during that process, it was the Ministry of Livestock and Fisheries that dealt with the complaint of the low feed quality. And I think it was a very tedious process trying to reverse issues on the purchasing and supply. So they ended up just going ahead feeding the fish with that feed, and then later on changing to a better feed. So I would safely say I think the monitoring is not properly done, but I think it should be monitored by the fisheries department. Yes.
I think in terms of harvesting, I know that it has a lot to do with the location of the farmers. So farmers in more rural and isolated regions don't have access to kind of like regional markets that more peri-urban farmers do. And so they either sell directly to their neighbors or they use the pond just as subsistence for eating within the household. I know that in Luwingu and kind of like the larger towns where markets do exist, there is some occurrences of aquaculture farmers selling into the capture fisheries markets.
Yeah, I think they do sell to those who trade, the vendors. And I think besides that, they also sell, I think there was a project with Oddfish where they were trying to link small scale farmers onto retailers, such as big shops. I think Triple Blessings, I don't know what to
classify. Like linking farmers to like businesses like hotels and restaurants and stuff. But keep in mind that all these aquaculture farmers exist in a region where there's a huge amount of capture fisheries trading, so wild fish that are entering the markets, and that's one of the reasons why aquaculture is promoted in these regions, not only because the region is compatible for fish production, but also to relieve some of the pressure that's on these natural water bodies.
Okay, thank you.
Zinfrey, did you have a question?
Yes, I do.
Oh, all right, over to you.
Try and envisage conceptually what the future may look like when you are back from your field trip. You've been to Zambia and you're back from your field trip. Now, my question to you is, at that point, is this: what were the conceptual problems that you encountered in your research in Zambia? You are now back with Mike after the project in Zambia.
No, he's in Zambia. He's in Zambia.
Yes, he's in Zambia. He's back now from Zambia. He's in State College.
He's back.
Are you saying like what mistakes I made
early?
No.
What conceptual challenges do you think will become clearer to you when you are back, right, in State College after the project, after you've done your fieldwork? Yes.
Yeah, I think so I'm originally a forester, right? And so when I came over, to me, the concept of agroforestry management was like yes or no, right? So does a farmer do agroforestry or does he not, right? But what I'm starting to learn is more and more is that there's actually a gradient of agroforestry that's utilized between all farmers. All Zambians use agroforestry to some extent, either through indigenous trees, like the preservation of some of these legacy trees that exist after slash and burn, all the way up into intensive production of these specific leguminous trees that we mentioned. So that's one thing that I'll say. Is that for me, I thought the agroforestry question was a yes or no question when actually it's a gradient of management, right? And I'm hoping that I can get a handle on, and I haven't seen this in literature, about the role of diversity. So a lot of these studies are looking at what types of feeds farmers are using, but I'm kind of interested not only in the types of feeds that farmers are using, but whether or not having a diversity of feeds that are available on the farm gives farmers like more flexibility during like times of feed shortages or feed depletion on the farm, that there's lots of different resources that they can pull from to be successful. So those are the two things that I'll mention.
Okay, thanks.
We have a question from the Dabari, but would you like to come on and ask it yourself? Feel free to unmute yourself and ask if you'd like. Otherwise, I'm happy to read it. Okay, yeah, no, you're all right. Sounds good. So the question is, are there any ways to make sure that fish farmers, both small and large producers, don't destroy sensitive habitat while creating their farms? For example, I know of some fish farmers, not in Zambia, placing their farms in sensitive mangrove ecosystems and disrupting the native system as a result without any legal or enforcement repercussions.
You want to try that one? I'll throw in some things at the end.
Well, with that particular question, I think there are some policies that are being developed. I think in the last project I was on, under the same Zayade project, they are trying to look at how best they can manage the natural water bodies, the capture fisheries, because over the years there have been a lot of fish depletion, and then there's been, due to the promotion of aquaculture in Zambia and the use of now tilapia, which is the fish that was imported, I think it should be from Egypt. It's kind of causing these problems by creating hybrids within the water bodies with Orechromis andersoni. So they are trying to find ways in which they can try and protect the natural water bodies, both from the fish that is being cultured by the water banks encroaching the river systems, and while also taking into account the economics, because I think it would be difficult to just pull out a fish and stop people from producing it, because I think in Zambia now tilapia is one of the big fish that people do consume, but it does have these effects of changing the genetic makeup of other fish. Then besides that, I think there are also policies that they're trying to formulate with regards to seeing how best they can incorporate all the different enterprises that are being done by the water banks, both aquaculture, agriculture, the use of fertilizers that are being washed away when rains come into the water bodies. So I think I'll just safely say there are some policies being done, but I'm not sure to what extent those policies are being implemented or being developed.
Yeah, like the person who asked the question specifically mentioned mangroves, which I think is like a problem that became huge in Asia and Southeast Asia, where integrated agriculture, aquaculture systems were first developed. Because keep in mind that these African systems were adopted from sustainable practices that were brought over from Asia. Now, since aquaculture has exploded in Asia, right, they're having all these problems with the degradation of coastal resources, right? Because farmers, once they have access to more intensive inputs, dump fertilizers and commercial fish feeds in the water, it can cause lots of environmental externalities. In Africa specific, I'd like to mention a few things. First, a lot of these ponds are put into communally managed areas that are owned by the chief and distributed to families within the region. So these areas are dambos, which are like low-lying swamplands with few vegetation. And for me, I struggle with this question because I recognize it as kind of like a trade-off. Because right now, specifically Lake Bangweulu, which we're talking about here in Luwingu, is being overfished, right? And so the populations are growing. It's putting lots of pressure on native fish populations in the lake is being depleted. And so aquaculture is seen as a way to like relieve some of the pressure on these native water bodies and give native fish the chance to breed. But then by doing that, you introduce some of these nutrient and fertilizer problems. And I think that hopefully as aquaculture develops in Northern Province, the government has the foresight to put policies and sustainable practices in place. By the way, I would like to mention that some of these sustainable practices that are being promoted back in America to filter out sediments and nutrients from agricultural runoff is agroforestry. So like intentional plantings of trees near kind of these runoff areas where trees capture some of the nutrients and sediment runoff coming from agricultural, aquacultural production. So that's actually one of the reasons why I'm interested in it, because I see it as kind of like a water, energy, food nexus type thing where we're trying to design systems that have the forethought to address some of these environmental problems.
Wow, that was excellent, fantastic response. Thanks, Jacob. I'm gonna now read out a question from Tembi, who asks, is the fish farming industry male dominated? Could you talk a little bit about how?
Oh yeah. Oh yeah.
Yeah.
Oh yeah. Yes.
If I could also maybe add to her question, because that was my similar, I was thinking thoroughly along the very interesting dimension of gender, which it seems kind of buried in your talk, that 100% of your farmers are women. And so I wondered, will your 60 women that or farmers that you're going to be working with in the next round also be women? And maybe could you talk about whether there's any sort of aspect of this that is shaped by only working with women? So
I'm glad you noticed that,
anything to say on gender would be great.
Yeah, I'm glad you noticed that, because actually me and Malaya just had a real in-depth discussion about that just the other day. Because keep in mind that the focus of the Prunsar study, which by the way I used as kind of like an in to Luwingu. I was kind of like a hitchhiker on the projects that Malaya and his colleague Lulu were doing in Luwingu, and I used it as a way to test my research tools. But the focus of that Prunsar was training farmers to adopt new practices in aquaculture, and they were directed towards women, which doesn't really give a balanced view of aquaculture management, because like we said, most aquaculture farmers are men. But there are, I don't know what the percentage is. I think it's like 20%, less than that, 15% are women managed. So in the future, so like I kind of had to work within the constraints of the farmers that we were having contact with within the Prunsar study back in 2019 and 2020. So as we do it this next time, we hope to focus on a more like generalized sample farmers of different wealth, high and low income, a representative sample of like a proportion of male and female farmers, and a representative proportion of like farmers who are in peri-urban versus rural. So we hope to get variation in sample with that, but more representative samples of men.
I think the other reason why more women were targeted in the project that was just mentioned was because women are the main food preparers, and they were trying to encourage women participating in aquaculture so as to provide food for their children, given the northern province, I think was, according to studies that were done, was ranked as one of the highest malnourished areas that had a lot of undernutrition and things like that. So to try and combat that, we identified women as the main food preparers, and they could easily use the fish resource to feed their children so as to combat stunting and other challenges that would be caused due to lack of the nutrients that are found in fish.
And just to add one more thing off of what Malaya just said, kind of the direction or the more extension promotion of aquaculture technologies are being done regionally in Southern Africa, and it's been recognized that directing extension activities towards women is one of the main goals of even other countries such as Tanzania and Zimbabwe and DRC. Anyway, they're recognizing that not only fish production is important, but also use of fish within the household. And since women are the main food preparers within the household, more and more extension activities are being directed towards both men and women, particularly trying to get women to be more involved in the head and management of the pond.
And I think
Because
that
probably most likely the division of household labor, women are probably doing a large majority of the work anyway. So,
yeah, I think it would be a good idea also to have a woman in your research team if you're going to.
next time.
Yeah.
Did you
Yeah,
want to
this is
jump in?
possible.
Oh, Tisa, go
Hi,
for
Tisa.
it. Do you
Hi,
want to
hi.
jump into this? Hi.
Hi, thank you. Thank you, Jacob, for a very interesting presentation, Jacob and Mulaya. I think I actually had the pleasure of meeting Jacob I think a few days after you arrived in Zambia. I used to work with C4 at the time, so you came and made a
Oh yeah, I gave a little talk. Oh, I
yeah,
remember.
yeah,
Hey, well, it's good to see you again.
yeah. Good to see you too. And
Yeah.
yes, Wamulaya Mawomben. Yeah, okay, yeah, okay. I think my question is, I know pretty much nothing about aquaculture, but I'm interested in the farmer's agency, their ability to choose what to use, when to use it, and the like. And in so doing, my question sort of also hinges on what Tembi was asking. You've already answered why women, but then my question is how, if, for instance, the historical evolution of the bioresource base, you mentioned it somewhere in your objectives, if that is part of your interests, and if it is, I'm curious to know how you would capture that, given that you're only targeting women who have worked for maybe greater than 3 years, when even though it's male
Hey, Tita, sorry, our connection was bad for just a second. Can you just back up and repeat your last sentence?
Okay, sure. So what I'm saying is, I'm curious to know why perhaps you wouldn't target men, maybe even for the basis of comparison, in terms of if you're trying to understand, maybe I'm interested in things like the knowledge transfer in terms of the experiences of the farmers in the field. So you look at men who historically have been, in the aquaculture business, maybe slightly longer, if they've learned new methods and new techniques or hybrid sort of feeds, for instance, that may be transferred to the women through their interaction with them. So I'm interested to know how you would capture this, if it is of interest to you, and if not, if anything to do with even sampling a few men would be within the scope of your study.
Yeah. Do you mind if I take this? Just to repeat, so women were targeted in the pilot study, and that I kind of had like no control over. I was just mostly trying to test out my tools. For this next stage of our research, we are targeting lead farmers, which are most often men. I mean, that's just the nature of the industry, right? And I think one of the things that I've heard from development professionals, not just in Northern Province, but Luwingu, is that they're interested in talking to farmers who have been doing fish farming for a long time, because there's a lot of fish farmers who've been doing this for like 10, 15 years,
Yep.
Because it started being promoted back in the 1980s.
Mm-hmm.
And it's those guys who I want to talk to, because they have the most experience, but they've probably dealt with conditions of feed shortages the longest and have developed kind of innovative ecological ways that are more ecological, innovative farm system designs to accommodate feeding during times of need,
yeah.
during times of feed shortages. And that's one of the primary questions that I put in the questionnaires, was what feed resources are you using when times are lean, when you can't find anything else? And I hope to ask those questions to farmers who've been doing it for a long time, because most likely that's where the most innovation is going to be found.
Yeah, that's true. It would also be sort of interesting and fun if you were to find some farmers who started in the beginning and then stopped and then joined afterwards to try to identify what incentivized them or encouraged them to pick it up again. Sort of get a feel of the social institutions and structures that are there. Thank you.
And just as an interesting statistic here, so aquaculture is still growing within northern provinces. I think the latest census report that came out was that most fish farmers that are currently doing fish farming in northern province have only been doing it for 3 to 5 years. So most of them are recent adopters.
Yeah. Yeah, thank you.
Yeah, sure.
Just a last question also came through from Temi, and I would be interested in it too, just on the question of women and wondering whether women might have challenges that were different to men, and also whether women would use different feeding methods than men. If any of that is visible in what you've found so far.
I'm going to hand that to Malaya because he's the one who worked directly with these farmers for like an entire year. So Malaya's your guy for that one.
I think in terms of resource use, I think there isn't much difference in what resources they would use. I think the only challenge why I think it is a male-dominated industry in Zambia is issues to do with land ownership. And I think mostly the social structure is such that men are the heads of the house within their households. So you do get to find that they're the ones that are given access to the land that they use for aquaculture. So in the previous, the pilot project that Jacob just mentioned, we had to kind of make an arrangement where the men would transfer land ownership to the women so that the women could kind of take control of the pond ownership to kind of see how things might be done by women in charge. But I think by looking at the data that was collected, I think there wasn't much difference between the two in terms of the resources that were used in terms of feeding the fish. But however, there were some challenges in terms of, I wouldn't know whether it's the social construct, but when it came to labor, building and constructing ponds, women would often complain to say it was a labor-intensive activity, and they would tend to hire men to do it for them. But others would group up as women to dig out ponds, and those that did that, I think, had more grip on the production that they did, and mostly those that would also have much control on the production system were those who are widowed or divorced. Yeah.
And so the questionnaire that we're going to be doing here in the next couple of months, a big part of the questionnaire is the division of labor roles within the household, both generational and gendered. And we'll be doing that for all sorts of tasks within aquaculture, agriculture, livestock, and forestry. And so that's one of that question that you asked is one of the things that I'm interested in, is where could there be potential synergies or trade-offs in labor distribution of these different tasks that are associated with like more sustainable systems. Is like where can we find tasks and activities where kind of resource transfers that women that are primarily women dominated can be paired in agriculture and aquaculture to create a more efficient system. And the same goes for men and children, so on and so forth. I hope that made sense what I just said.
And I think to also just add on, sometimes I would say it's not every household where people do allocate tasks based on gender, but I think it's just based on what's logical. Yeah. So that's something that would be good to try and capture.
So there was so much data that from the pilot study, I actually had a whole separate like qualitative section specifically about this question related to labor, and I just didn't have time to present it. But actually, a lot of studies that have been done in aquaculture up to this point just ask frequency questions: who does what? Men, women, boys, girls, right? But they don't ask why. And one of the things that I did was I just asked the same questions that everybody else is asking: who does what? Men, women, boys, girls. But at the end of it, I just asked, well, why do you do that? And I was surprised because I was expecting to find like more rigid, like gender roles. Oh, we do this because like women are responsible for this, and there was some of that in there, especially with like fuel wood collection, I don't know, other tasks like water fetching or anyway. But I was surprised to learn that a lot of division of labor roles within the household actually made a lot of sense outside of these strict gendered roles, and just made more practical land management sense of like who has time, who's where during certain times of the day, and who's in proximity to the resources that they're managing. And sometimes it's just completely logical what they're saying, as opposed to these like strict gender divisions that people, I guess, assume that are the reasons for the division of labors. Sometimes they're doing it just because that's the person that's available, or they're just good at it, or, you know, anyway, there's all sorts of reasons. I'm sure I'll present it at my final dissertation presentation.
There's a whole, I mean, gender has become the topic, you know, so to speak, in terms of agricultural systems. Just and you know, there are a lot of myths, right? Like Jacob's trying to dispel some. I mean, you know, people have, obviously there are a lot of inequalities and issues, but anyway, we won't belabor that. But I just wanted to come back to the adoption issue. You know, I've just been thinking about one of the issues is actually making the dam, right? In terms of labor and capital. I don't know how much capital is used, and land availability, but you know, is that be interesting to know. I mean, you're not really interviewing farmers who don't have a pond, but is the reason that they don't adopt is the reason, how much is a factor in adoption of these systems because of the time and energy and cost to build the ponds to begin with?
Yeah, I think that could be also a major challenge, I would say, because not everyone has the financial muscle to hire people to dig, or the labor within their household to dig the fish pond. So I think that could also be a challenge.
Yeah.
Yeah.
So I'm just wondering if that's a bias. You know, the type of farmer who builds a pond might be different to the average farmer just because they have more resources to begin with.
Well, I mean, the same issues are in agroforestry too, Mike. I mean, if like, you know, I've read all the literature that you've supplied me about agroforestry, and that's kind of the same problem when making comparisons between farmers who adopt some of these more sustainable tree management systems and those that do, is that farmers that have, you know, more wealth or security, they kind of have the freedom to like experiment, the freedom to like adopt things that that are out of the ordinary because they have the security to make that decision. So I think it's just like any sustainable practice. Doesn't there have to be a certain level of resource acquisition before a farmer is able to take risks? You know what I mean?
Yeah, no, but that's where, you know, assistance can come in to help the other farmers, so to speak. But anyway, I don't know if Michelle, if we're done, I don't want to go over time.
Are there any other questions? Anyone else? Okay, in that case, yes, we can draw this to a close. And thank you so much, Jacob and Leah and everyone for this. It's been really interesting.
Thanks.
Thanks for doing it.
Thank you very much.
Take care.
Thanks.
All right.
Hey, y'all have a good day.
Bye.
Take care, everybody. Good luck with your research.
Hey, thanks.
Thanks, Michelle.